Whoa there! You fight with the strength of many men, Sir Knight. I seek for knights to join me on my council at Camelot. I am King Arthur, Lord of all Britain. You have proven yourself worthy to join me in my quest for the holy Bundt. You make me sad, Sir Knight. Squire?
None shall pass!
Excuse me.
None shall pass!
I am King Arthur, Lord of this land.
I move for no man, except he who can soften the volume of this Bundt!
In order to find the quartic area and volume of our Bundt cake, we have to find a scalar first and foremost, and the way we did that was using two x-intercepts from previous functions, which is 4 and 9, and in this case we only use two x-intercepts. And so, plugging that into the general equation for quartic, we found the scalar, which is this value down here, and we substituted all those values back into the general equation, which is this function down here. And to find area, we just take the definite integral from 4 to 9 of this function, and we get this value. And to find volume, we have 2 pi times the definite integral from 4 to 9 times x times this function, and we have this value.
So there, Sir Knight. I have solved your problem.
I wanted it in hyperbolic trig form!
Then we battle!
Tis but a scratch!
You have lost, Sir Knight. Stand aside.
Tis but a flesh wound!
Cede the battle, Sir Knight. You have lost. Come, Squire. Who are you?
We are the knights who say
The knights who say E? Those who hear them seldom live to tell the tale. We simply want to pass. What do you desire?
In order to pass through these part of the woods, you must appease us.
Oh, we are but simple travelers who seek the holy Bundt. What do you want?
The Bundt!
A Bundt? A Bundt?
Yes, matching these equations. Not too big, not too small.
To find our trigonometric function, we have our standard trigonometric function. We have the points 4, 0 and 9, 0. So, because the parent function y equals sine x intercepts at 0, 0, and we would like it to shift 4 units so that it would be 4, 0, we set our c value equal to 4 to horizontally shift it. Then afterwards, half a period, we would solve for half a period, which is equal to 9 minus 4, which is equal to 2 pi divided by 2b, and our b value is equal to pi divided by 5. And then afterwards, because we want an amplitude of 8 units, because that is our maximum, we would set our scalar of a equal to 8, and therefore we can plug in our values for our trig function. Now, because we are able to obtain our trigonometric function, we plug into area integral, which has the limits of integration from 4 to 9 of our function, which we get our area. Then afterwards we plug into our volume, which is 2 pi times the integral of xy, which in this case is our function, our trigonometric function, which then we obtain our volume.
Knights who say E, we have brought you your Bundt.
Very good. But we are no longer the knights who say
Oh,
we are now the knights who say 2 pi integral xy dx.
what? Please, just take your Bundt.
Very well.
Come, Sir Lancelot. Let us depart. Behind the calculus student is the threat?
No, it is the calculus student.
He's only a calculus student. Sir Galahad, attack!
Don't worry, my liege. I'll have him taking trig in no time.
It is worse than I thought. Bring me the holy hand Bundt of Antioch. How do we use it?
You must calculate the volume of the Bundt cake using a quadratic equation. Then you must count to 2 pi and release the Bundt.
First, we plugged in our measured values into the vertex form of the equation. After expanding it, we substituted estimated values of our vertex in as x and y. After simplifying this to get our a value, we plugged it back into the original equation and then finally calculated our final equation. Then, taking the definite integral of the same equation with the limits of integration at the x-intercepts, we got our area value. Then, using the formula 2 pi definite integral of xy dx, we were able to get our volume value.
Very good. 1 pi. Tau!
2 pi, my lord!
2 pi! It is the bridge of death. They will ask us 3 questions. Brave Sir Robin, go.
Action.
Stop! He who wishes to cross this bridge must answer me these questions 3. What is your quest?
To find the holy Bundt.
What is your name?
Sir Robin.
What is the derivative of x squared?
2x.
You may pass.
Thank you.
That's easy!
Stop! He who wishes to cross this bridge must answer me these questions 3.
Go on.
What is your quest?
To seek the holy Bundt.
What is your name?
Jason De Leon. I mean, Sir Lancelot.
Stop! He who wishes to cross this bridge must answer me these questions 3.
Get on with it.
What is your quest?
To seek the holy Bundt.
What is your name?
King Arthur, Lord of Britain.
What is the volume using a trigonometric function of this Bundt cake?
Using normal trigonometric functions or hyperbolic ones?
What? I don't know!
For our hyperbolic cosine equation, we built an equation based on this general form of a hyperbolic trigonometric function that we based ourselves off of a standard trigonometric function equation. So this is fresh out of the oven, fresh cookies out of the oven. Basically what we did is, similarly to a standard trig equation, we used a vertical stretch, a horizontal shift, and a vertical shift as components in our equation so that we could find them and find a good equation. First off, we knew that our vertex would be at 6.5, so we knew what our horizontal shift had to be, and that's c equals 6.5. And from there, based on our points at 4, 0, 9, 0, and 6.5, we were able to write a series of equations that we could solve for an appropriate expression. Basically what we found is that our A and D values, our amplitude and our vertical shift, are interdependent given our maximum height, and that we could write an equation here that relates our maximum height to our horizontal stretch, as you can see here. And so we arbitrarily assigned a value of A equals -1, knowing that that would later change our D value. And for this A value, we found a horizontal stretch value of 1.155 and a vertical shift value of 9 that would give us the correct maximum and x-intercepts. We then used our typical area equation, the integral from 4 to 9 of that function, to find our area, and we used our typical cylindrical shell method to find our volume.
Sir, how do you know so much about calculus?
You have to know these things when you're a king.
We've finally found it. The whole...